Number 14, integral of x cubed over square root of 1 plus x squared dx. I'm going to solve this in two different ways. This will be good practice for you too if you're studying for your exam. We can do this with a typical u sub, or we can do this with a trig sub. So I'm going to do the u sub first. Okay, so let's rewrite the top as x squared times x. Leave the bottom alone. And we could let u be 1 plus x squared. So du is 2x dx. Okay, so let's start substituting. The bottom's simple enough. It's square root of u. What about the top? Well, x squared is u minus 1 if we look at the definition. So u minus 1. And then x dx is half du. Okay, so let's clean things up. Let's pull the half out in front. And then we can divide through by the square root of u. So it becomes u to the half minus u to the negative half du. Okay. Power rule now. So half times 2/3 u to the 3 halves. This is u to the half divided by half. So minus 2u to the half plus c. Let me rewrite that one a little better. And then we got to back substitute, and we can simplify a little bit. Okay, so this is 1/3. What is u? 1 plus x squared to the 3 halves power minus square root of 1 plus x squared plus c. Let me double check this is the right answer. Looks like it. Good. Matching my previous one. Okay, so we can do this u substitution here. All right, now as practice, let's do it with a trig sub. Because there's a radical in this, and inside the radical, there's something squared plus something squared. So we can do a trig sub. So start setting up the triangle for the trig sub as I finish erasing this, if you know how to do that. All right, let's draw a right triangle with some angle theta. So since it's something squared plus something squared, we know that 1 is one of the sides, x is one of the sides, and square root of 1 plus x squared by the Pythagorean theorem is the hypotenuse. Okay, so we want to substitute everything in the integrand in terms of theta. So we need x. How can we get x in this triangle? Well, x is just tangent theta. Tangent theta is x over 1, opposite over adjacent. So dx is secant squared theta d theta. Okay, and we can get the square root term as well. Square root of 1 plus x squared. What is that in the triangle? That is secant theta. All right, so let me shift this over to the side. Put it over here so that I have space to write my integral. So what's x cubed? X cubed will be tangent cubed. Dx is secant squared theta d theta. And the bottom is secant theta. Right, so let's start simplifying. Well, we can divide through by the secant. So instead of secant squared on top, we'll just have 1 power secant. Okay. Now this is a trig integral. Can we do a substitution? So what I'm thinking right away. Well, it doesn't look like we can let u be tangent because there's no secant squared. That's there, right? Maybe let's save a factor of tangent out. See, I don't memorize those rules, but it looks like we can do this. So then secant theta, tangent theta, d theta. And then tangent squared is secant squared minus 1. Okay, so now we can let u be secant theta. So du is secant theta, tangent theta, d theta. So we get u squared minus 1 du. Now it's a simple power rule. So it's 1/3 u cubed minus u plus c. We got to back substitute twice though. So what's u first of all? It's 1/3 secant theta, secant cubed theta minus secant theta plus c. And now we got to substitute secant theta because our original variable was x. So what's secant theta? We have it right here, or we can look at the triangle, and you'll see that we get the exact same answer because this is to the half power square root, right? So 1 plus x squared to the 3/2 power minus square root of 1 plus x squared plus c. Here is our answer with trig sum. Maybe we can do it in another way as well, but this is the two ways that I saw can be solved right away when I saw this integral.